you hear Mickey Mouse going on.
Yes, now I have a Mickey Mouse watch. Okay, we're going to talk some more about Venus and maybe get a little into Mars today. I know I started Venus a little bit early on Wednesday. So let's get going. You've seen this picture, well, something very close to this actually. It wasn't this picture because it wasn't a full Venus. This is a full Venus. Venus goes through phases. Who is the person who studied the phases of Venus that we talked about? Galileo. What was special about the phases of Venus as Galileo determined? Well, what about the phases? It had to do with going about the sun, but the phases themselves.
I don't know what you're going for.
Well, you have different predictions about the phases depending on if Venus is going around the Earth or going around the sun. If Venus is going around the sun, then it will never have a new phase. But if it's going around the Earth, it will have a new phase. And what was determined by Galileo's observation was that Venus never has a new phase, or excuse me, yes, Venus never has a new phase. I got to make sure I say it right, otherwise I feel stupid when I listen to this later. Venus never has a new phase, which means that it can't be going around the Earth. Here, that was ultraviolet light. You've seen this topographic map of Venus that's looking at elevations on the surface. So now, last class period, I just kind of zoomed right past the surface features. You do have large impact craters on Venus. Now, on the surface of Venus, you don't have liquid water, but you certainly have atmosphere. Which one does a better job of changing the surface? Water or air? Water. Now, keep in mind there, the air is, like 90 times to 100 times thicker than the air here, but that's still 100 times less than water. So you still have much less surface erosion than you have on Earth because you have no water to do erosion on those features. So you see very clear craters. That there, of course, inside the red is the crater. The stuff outside that you see is called ejecta. It's stuff that was ejected out when you had the impact. Now, the object that impacted is not the size of that crater. The object that impacted is going to be smaller, and that crater is stuff that was flooded over or excavated out with the impact. If you go to the Barringer meteor crater, it wasn't flooded, but all that stuff got moved out with the impact. So we have here just a couple different craters from impact. So we see that we have had impacts on the Venusian surface. We have these pancake domes, called pancake domes because I'm hungry now. I didn't get lunch today. And those look like pancakes. I didn't get lunch today. I did get breakfast, just for the record. So those pancake domes are actually the result of volcanoes. You had magma come up and flow out and make these, much like the Hawaiian Islands. The Hawaiian Islands are called shield volcanoes because the magma comes up and it flows out instead of having a dramatic pyroclastic explosion. So they look different because of the type of volcano. This here is just showing cracks and folds on the surface, signs that you've had stress on the surface causing it to deform. We talked previously about the mountain ranges that were formed by the Pacific plate sliding under the North American plate, creating the coastal range, the Sierra Nevada range, all the way out to the Rocky range. And Awan, we talked about his mountains, the Himalayas, something like that are also the result of the same type of action, but in his case, of course, it was the subcontinent of India slamming up into the continent of Asia. So we have signs of plate tectonics. We have impact craters, similar things to what we see on Earth. So that tells us that we expect everything else that goes along with those, the things that cause them. Remember, the plate tectonics is caused by having a fractured crust with convection in the mantle. So we expect to have similar things there on Venus. The atmosphere is obviously different, but we still see the same general feature of it gets colder as you go up away from the surface in the troposphere. And you get up into the stratosphere and it just remains pretty cold. It gets warm as you go way up high. What's most different about this is the gases and the pressure. So you have an atmosphere of carbon dioxide, and then you get up to those nice, anybody know what H2SO4 is normally called? Sulfuric acid. Sulfuric acid clouds. It's a nice place to hang out. You know, you definitely fly your airplanes in that. So it has a, yes, that was sarcasm, sorry. It has a very caustic environment as far as the atmosphere. Now I'm shifting over to Mars. So these are the best pictures of Mars taken from Earth. These are actually pictures from 1988. That's the year I graduated from college, in case you need a reference point for my age. You look at those, I mean, those look pretty cool, right? But that's the best we have from Earth. You've certainly seen better pictures of Mars. Let's look at the pictures of Mars that really got people going, you know, about those little green men from Mars. You guys heard of little green men from Mars, right? Here is the person who probably is responsible for a lot of that. Lowell Percival, a very serious astronomer, who, I said Lowell Percival, Percival Lowell. Either one could have been his first name, right? Just said the wrong word. He was an Arizona-based astronomer, not originally from Arizona. He went out there, was studying the sky, and he specifically did a lot of studying of Mars. I know this is a picture of him when he was looking at Venus, but did a lot of study on Mars here, looking through his 24-inch telescope. Remember I told you that's not what astronomers do anymore. But that is what they did back in the day being my grandfather's day, or great-grandfather's day. And what he saw were patterns that he called canali, which is, I think of it as an Italian term for some kind of, you know, pastry, a noodle or something. Pasta or pastry is what I meant to say. But no, it's actually Italian for canals. And he said he had found signs of extraterrestrial life, that you have these what clearly look to be man-made canals for people to travel around like they do in Venice. And he wasn't the only one who saw what they thought were canals on Mars. And so people thought they'd found signs of civilization on Mars. Here's our best picture today of Mars. That's taken from the Hubble Space Telescope in 2001. And do we see any signs of actual canals? No. No, we don't. And in fact, we have done a lot, we as humans, not we as, which I always have to point that out because I use we all the time. Done a lot of study and have found no signs of life on Mars. Now, I'm going super fast. I'm probably going to finish this lecture early because I'm only 10 minutes in and I think more than halfway through my slides already. We might have an early break time. We have not found signs of anything resembling humans on Mars. But there are things that some people will point to. They say there had to have been human-like beings there. What we have found on Mars is finally, after extensive search, signs that there is still water on Mars frozen away, and that there probably in the past has been liquid water on Mars. If there's liquid water on Mars, I talked about Dan Quayle before, if there's liquid water on Mars, then it could be conducive to life on Mars. And so there's been a lot of search there to look for that, and they found that aspect, which means that life could possibly exist there. Humans, if we had oxygen tanks for something to breathe, and if we had a structure to keep the temperature appropriate, we could have, if there's water for us to breathe, or drink, water to drink, air to breathe. You know how it goes. Food to eat, have to supply your own food, we could live there maybe. So, what exploration has been done? I decided, I know that little thing is blocking the words, but you're not supposed to read those words anyway. They're just there for those who aren't listening to me. You're all listening to me, right? We had a talk to be in school year, and the lady was saying, I never use a font smaller than 44 on my things. Students either going to listen to you or read up there, so I put very few words up there so they'll listen to me. I just assume that I am so scintillating, you would never deign to just read the words. So I'm going to focus on the successes of our Martian study. And recent days have been mostly successful. So starting with Pathfinder and Sojourner. Pathfinder was and I have some timelines on the next slide. Pathfinder was a science lab, if you will. Not a manned science lab, of course, but a science lab that was landed on Mars. And inside that science lab was its little rover, Sojourner. So in this picture, which is taken from Pathfinder, you can see the ramp out of Pathfinder. You can see the tracks where Sojourner left Pathfinder going down that ramp and is out there studying that rock. So it's a little robotic rover. And as we'll see on the next slide, Sojourner had a useful lifetime of 80-some souls. What in the world is a soul? Anyone want to offer a guess? What does the word soul mean to you? Sun. So soul is the term that they use for a day on Mars or on any other planet. Soul would be the time from noon to noon. And so soul is a day on Mars, which turns out to be 24 hours and 30-some minutes. I forgot how many minutes. It also says that on the next slide. So it lasted for a little over 80 sols. It traveled under 100 meters in total. Keep in mind, this is 2 meters. So its total distance traveled was less than 50 of these. And it never got more than 10 meters away from Pathfinder. So it basically stayed within the area of this classroom from its lander. So it just steadied all the rock nearby. Now, before we move on to the next slide, when you look here at the surface, what do you see when you look at the Martian surface? What stands out? The color. Okay? The color has, I don't know, what you call it, ochre or something like that. Has a reddish tint. Why would it have a reddish tint? Iron. There's iron in that soil, and when you have iron in the soil, it rusts, it oxidizes, and the iron oxide gives you that reddish color. When you see red soil on Earth, it's the same process. You have some iron in there that's giving it that color. So they studied the soil samples, of course, to determine indeed that's what it is. It's not just a hypothesis. It's now measurements to say, yes, there's iron there. So what else do you notice besides the color? Rocks. A lot of rocks. That would not be your happy place for frolicking and rolling, right? It has not gone through much slow surface evolution. It has a bunch of broken up rocks. And in the background, you see mountains. So it has mountains. In fact, we'll see later, it has the tallest mountain in the solar system on it. So it doesn't look that unlike here. Now, distances are hard to judge. One reason distances are hard to judge, there's virtually no atmosphere, about 1/100th. So Venus is 100 times more dense than Earth, roughly. Mars is about 1/100th of the density of Earth's atmosphere. So it does have atmosphere, but even if it's 100% oxygen, it wouldn't help you. It's just not thick enough. And so that means that you have very little anything to distort light so you can see for very large distances. So those are not necessarily, within 50 miles. So here is our success stories. There are plenty of failure stories. I just decided not to focus on failures today. So we have the Pathfinder mission that was launched in December of 1996 and finally reached Mars in July of 1997. Notice that's between 6 to 7 months for these times on all of these, when they left Earth to when they arrived. I don't think that's the fastest it can be done, but that's the typical. Making the transition from Earth to Mars can be done different ways, different amounts of fuel, and they try to figure out how they can do this on a reasonable amount of fuel in a reasonable amount of time. So it took, in this case, that'd be, 7 months, right? Yeah, 7. It landed on July 4, 1997, and the next day, out rolled Sojourner, and Sojourner then operated for 83 sols. Here's where this is the first one I put in, that's why it has the definition of sol. I put in Pathfinder after I put in the Mars exploration rovers. So one sol is 24 hours, 39 minutes, 35.244 seconds. That's how long it takes from noon to noon. That would be a day on Mars. Okay, so that was a pretty short mission. Now, the Mars exploration rover mission was intended to last 90 days. This one here lasted 83 days for its rover. I figured that's probably a good landmark. Go a few more days, it should all be good. And so it landed. You actually had 2 different missions here, MER-A and MER-B. MER-A we call Spirit, MER-B we call Opportunity. So MER-A, Spirit, was launched June 10, 2003, and roughly a month later, Opportunity was launched, July 7th. Now, you guys were all really young then, right? Alive but young. So you probably don't remember this. They arrived in January. Notice they arrived closer to each other than when they left Earth, of 2004. And almost immediately one of them lost, I think it was only one of them, lost contact. And everyone was like, oh my goodness, all of this money and we're getting nothing from it. Well, after a lot of thinking and working, NASA figured out what was wrong, was able to resurrect it. And these have had amazingly successful careers after what appeared to be dead on arrival. So Spirit operated until May 1 of 2009. So that's 5 years and 4 months of operation. Then it got stuck in some loose soil. Stuck in some loose soil means it can't go anywhere. And so NASA said, okay, we have already gone way past expected lifetime. But its measuring instruments are still working. So let's make this a stationary lab now and just continue and learn everything we can about the immediate vicinity where it's stuck. And so it continued on there from May 1 of 2009 until, I do have in there, but I was trying to adjust columns because it was printing down below, and apparently it's printed down here. It was, well, no, I guess they have. It stopped communicating on March 22 of 2010. So basically another year of staying put, and then it went to kaput. So For its 90-day lifetime, it got a total of 6 years and 3 months. Not bad for 90 days. Lots of data, lots of pictures. And then there's opportunity. Opportunity started a couple weeks later, and it went to hibernation mode on June 12 and hasn't come out of hibernation mode yet. Does that mean it's done? It might. Why is it going to hibernation mode? Because you have storms on Mars. It has an atmosphere of 1/100th as thick as ours, but when you have a storm, you have real dust storms. And so those dust storms will cover its solar panels. Well, if the dust storm covers your solar panels, you don't get any electricity. If you don't get any electricity, well, nothing works. So what they have is a setup. It will only operate when it has this much extra power. And when power runs low, it shuts down. And when it has the storm, it basically shuts everything down and goes into a hibernation mode. And then it will periodically try to check to see if things are okay. And if it gets a signal from NASA, because NASA's monitoring the weather, that says, hey, wake up, it will try to clear the dust that has been sitting on solar panels so that they can charge up again. And then when it gets charged up, then it'll communicate and things come back to normal. So it's not necessarily dead. It's supposed to do this. But 3 months is a long time. So it may be dead. But that's okay, because these were so successful that NASA sent up another mission, the Curiosity mission, that was supposed to last 2 years. Now notice, this Curiosity mission was launched after Spirit had died, and Spirit had a nice long lifetime. But still, they say, okay, we've got instruments, we figure everything should work this long. They had already far surpassed the expectation with the Spirit and Curiosity. So this one here, instead of 90 days, they planned for 2 years of mission. And then after 2 years, it was indefinitely extended. So they're going to continue using this Curiosity rover as much as they can. So you see November to August. That's a much longer flight time. Still operational. It's traveled almost 12 miles. Notice that Opportunity traveled 28 miles. I'll say so far because it could come back to life and continue to travel. And Spirit traveled almost 5 miles. So when we talk about the traveling, we tend to think that it's covered a lot of Mars. No. It's a lot more than Sojourner saw. 100 meters, never more than 12 meters away from the Pathfinder. Traveling 28 miles was a lot, but we still only have very small regions that have been carefully explored. So here's a picture from Spirit. And of course, to me, it's very entertaining to look at, what was it doing here? It's a little turning around and whatnot. There it's been traveling straight. How fast these things travel? What do you think? Slow. The Sojourner traveled around a centimeter per second. So that would be, not going very fast. None of these traveled very fast because you want to make sure it's as robust as possible. The faster things move, the more problems that could occur. So they travel pretty slowly. One of the things that stands out to me here is that looks like there's a lot of dust on that surface there. Now this part is spotless and clean, but that looks like it has a lot of dust. And so I at least like to think, well, maybe, it's been through a storm or something and picked up some dust there on the flat surface. Does the surface here look like the surface we saw in the previous picture? I see. Okay, it looks flatter. It looks like it has less rocks Still has rocks clearly, still looks red. So you see there is some variation, but there's also a lot of similarity, hence the other things on Mars. Craters. You have a nice big crater there on the left, sign of some kind of impact, meteor impact. By the way, the Japanese landed on an asteroid. I went back after class and checked to see if it was an asteroid or, comet, because I wasn't sure last time. It was an asteroid. They've got some pretty cool pictures that they've released of, the surface of that asteroid. This here, what's this? Well, it looks like a canyon. Yeah, I made it small. You can't read the words. It's the rim of the Victoria crater. It's a piece of the edge of a crater, not the same crater. And so you can see a cut in the rock there, right? This here is what we would call an earth or rock cut. And you see you have a layer here. So there's some variation there that's very similar to the type of things we see on Earth. But don't be confused. It turns out Mars is not very Earth-like. For starters, Mars is a lot smaller than Earth. Being a lot smaller than Earth, right, so it's 70-odd% the size of Earth, means that it should have cooled quicker, so its core is probably frozen. In fact, they have found signs of a frozen magnetic field that is like on the Earth's oceans. They found the frozen magnetic fields. They have those on Mars, but they don't have a current planet-wide magnetic field. So you draw a conclusion from that. What conclusion would you draw from that interesting observation? If it has frozen magnetic field on the surface, what used to be there?
Well,
No,
it would indicate that it was at least at one point very similar to Earth.
Okay, it had a planet-wide magnetic field similar to Earth, but it doesn't now. So if it did and doesn't, what would have changed? We talked about with Venus, it doesn't have a magnetic field, and we concluded then that it should have a molten core, and it's rotating fast enough, and so it must be missing convection. Now, Mars being a smaller planet, we come to a different conclusion. First of all, Mars is rotating plenty fast, right? It's rotating roughly the same rate we are. So it's not the rotation. Mars, being smaller than us, will cool a lot faster. So what outcome would you expect to cause it to not have a planet-wide magnetic field? Your hypothesis is?
Well, you just said that it had a magnetic field, right?
Yes.
So it had at one point convection.
It had at one point a molten core with convection. And so what would we guess it has now? Its surface is plenty cold, so if it has a molten core, it should have convection. So the conclusion then is its core must have frozen. Because, and I think you had a homework problem that had you do this calculation, but it turns out that the rate of cooling is proportional to the surface, let's see, it's proportional to the rate, the 1 over the radius. It's proportional to the surface area divided by the volume. Surface area, 4 pi r squared. Volume, 4/3 pi r cubed. And so you put that together, you have 3 over r. So the big ones, the ones with the big R, cool slowly. The ones with the small r cool quickly. And so it makes sense that it would have cooled enough that its core is now frozen. Okay, some more features. This is not a feature on Mars. This is a feature on Earth. This is a meteorite. Meteorite means that it is this part here. Well, actually, I should have circled the "ite" part. Means that it's a rock that hit the earth. Meteors make lights that go through the atmosphere. Meteorites are rocks that hit the earth. So a meteorite was a meteor before it hit the earth. That is believed to be Martian in origin. Found on Earth, Martian in origin. How would you ever conclude that this is a Mars rock if it's found on Earth? They compare the abundance of different elements, the isotopic abundance as we call it, to Earth rocks. They say, this isn't the same isotopes that we find on Earth. And they have determined, and I can't tell you how they determined it, that the isotopic abundances match what you would expect on Mars, not what you'd expect on Earth. And so they believe that this is a rock that was on Mars, something big hit Mars, broke pieces off, and this piece that flew off of Mars came and hit the Earth. Kind of cool, right? Here's looking at a topographical map of Mars. And when you look at this topographical map, there's some real significant features. What stands out to you?
The things on the left, I don't know what they are.
Okay, so these things here, those are volcanoes. I know, they look like zits, right? They're volcanoes. Okay, so there's one thing that stands out. Something else? Nothing else?
That part that looks kind of cracked, but like light blue right there.
This here?
Yeah.
Okay. That's a big canyon. It's Valles Marineris, the Mariner Valley. Other things that should stand out, this is a very low region. It's an impact crater. And this here is a really big region that's fairly smooth, something that had an impact and was flooded. So you have a lot of features that you expect from impacts, plus you have some features you expect from plate tectonics for having a canyon and volcanoes. Yes, it would. So let's look a little bit more. That's Hellas Basin, by the way, is the name of that region right there. It's the basin from hell. So here is a picture of Olympus Mons, Mount Olympus. Notice the picture on the right, which apparently comes from Buzzy.com. I found the image on a number of websites, none of which were Buzzy.com. The largest mountain in the solar system that we're aware of. Our textbook says probably the largest in the solar system. Like, where else are you going to find a larger one? Okay, the largest mountain that we're aware of in the solar system is Olympus Mons. Olympus Mons, it doesn't look like much in the picture on the left. Kind of looks like a cow pie from a sick cow. Just leave it at that. But on the right, you see it compared to mountains on Earth. How many people know what the highest elevation on Earth is? Not the number, but the mountain. I'm asking this for the benefit of Alwan, even though he's asked it. It's up there.
Oh, it is up there.
Everest, yes.
Not oh.
Mount Everest is the highest elevation on Earth. But it's not the tallest mountain on Earth.
No.
The tallest mountain on Earth is also shown up there, Mauna Kea. Well, how is it that Mauna Kea is the tallest mountain on Earth, but not the highest elevation, because Mauna Kea starts way down underwater. The vast majority of Mauna Kea is underwater. And so it's one of the Hawaiian Islands. And it's taller than Mount Everest. It's taller by 0.8 miles. Pretty significant difference, right? You put that into feet, and that's like, what, 3,000 feet or so? You hike around in Colorado, and you're really impressed by the 14ers. Mount Everest is much higher than that. But if you compare a 14er and a 11er, you know, my house is at 90, I think it's actually 9,600 feet. It's about, yeah, it's a lot above here. So Olympus Mons is more than twice as tall as Mauna Kea. And of course, it's going to have a mass that's way bigger than Mauna Kea's. Now, it is on Mars. Mars only being about 70% the size of Earth, the acceleration of gravity is smaller, which means that things don't weigh as much. But that much mass, it's going to weigh a lot more than Mauna Kea. Now, what happens around the base of Mauna Kea? Anyone have an idea? A heavy mountain, it sinks. So Mauna Kea sinks into the ocean floor. There's a moat around the base because the ocean floor has sunk under the weight. The crust has sunk down under the weight of that mountain. Why? Because we have active plate tectonics with plates that aren't all that thick. Right? The plate is only going to be on the order of 5 to maximum of 10 miles thick. Well, Olympus Mons has no such thing. There is no moat around this mountain. The surface has not sunk under its weight. So that brings a very important point to the conclusion. We already said we believe the core has frozen solid. It appears that the mantle must have a very thick crust or also be frozen. Otherwise, it should have sunk. There are, I believe, still volcanoes. You still have some magma. I say believe because I didn't look that up. Let's go past this to the Mariner Valley, named Valley Marineris because it was discovered by Mariner orbiter. So this is a huge, huge valley. If we compare it to the Grand Canyon, which we do in this picture down here at the bottom, we see that the Valles Marineris would span from the entire east coast to the west coast of the United States. Yes, I didn't notice it was upside down until just now. It doesn't look right, but yes, there's Florida right there. Yes, I can't write when I have it zoomed in. I don't think it was upside down when I put it in. You were coming into my office when I did it, remember? I must have screwed it up just at that moment. Everything was going well until that moment. Sorry, nobody else was there to hear them. So, that's a little embarrassing for me. And so right here, okay, you can see my hand, right? That is where the Grand Canyon is, and that's its size compared to this. This here is comparing the depths so clearly. The depth of Valles Marineris versus the depth of Grand Canyon. So it's much deeper. What caused it? What caused the Grand Canyon according to geologists? Erosion. Erosion from the river. The Colorado River flows through and over time, very, very slowly erodes rock. Now, if you are a young Earth creationist, what created the Grand Canyon? Water flowing much faster and thus eroding much more rapidly. As the vast preponderance of scientists say, no, the whole lot of water, short time doesn't make sense. And there are some legitimate reasons for that. It's not just because of bias. But that's not what anyone suggests here. Now, they do suggest there used to be water flowing on the surface of Mars, but that this here is actually the result of plate tectonic motion. That you had rifting here coming apart, creating those cracks. So it's believed that these are signs that there used to be active plate tectonics on Mars. And that brings me to the end. I only finished 9 minutes early. I've held you over a few times, so it works out.